My name is Roman Melnick from Transcat, and I'll be your moderator today. One quick bit of housekeeping that I'd like to get out of the way is that there's been a widespread internet outage this morning in the Northeast. Our connectivity was down most of the morning and recently has come back up. If for any reason we lose the connection again, we will reschedule the webinar. Joining us on the call is Phil Mistretta, Transcat's Manager of Metrology. He has a background in EMC, EMI compliance testing, lean manufacturing engineering, and over 25 years of experience in the field of metrology. He's a member of IEEE and ASQ and is an ASQ certified calibration technician. Phil is a graduate of Central Texas College. Today we'll spend the first part of our time in the presentation, and we will end the call answering your questions. Anytime during the presentation, you can send your questions through the question box right in your webinar controls. If we happen to run out of time before getting to all the questions, we'll follow up offline to the email or phone number you provided at registration. I also want to mention that this webinar is being recorded and will be available for you to view on YouTube. Just search for Transcat video as all one word, and we will also send an email with the links in the material to you once we've compiled them. Please feel free to share this materials with your colleagues. At this point, I'm going to turn the presentation over to Phil.
All right, welcome. Thank you for your time and attendance. I hope everyone can stay for the entire duration of the webinar. I'm shooting for about a 45 minutes worth of presentation and leave about 10 or 15 minutes for questions. So let's get started here. All right, so what's the big deal about out-of-tolerance equipment? When calibrated test equipment is found with an out-of-tolerance condition, there's additional risks to your products in which it was used. It's important to understand the magnitude of the potential risk because it can lead to dangerous situations and additional business costs. For example, everyone's heard about the huge airbag recall from Takata Corporation. Right now they're forecasting about a $218 million fiscal year loss. They're responsible for at least 4 deaths and 139 injuries. So there are costs associated with recalls and errors in production and manufacturing. Here at Transcat, we calibrate and process over 100,000 customer units each year. And roughly, we see about a 10 to 15% out-of-tolerance rate for customer equipment. And internally, we have over 8,000 calibration standards and assets. And you can bet that we find some of them out of tolerance, just like every other calibration lab out there. So we kind of have a little bit of familiarity with this and deal with this on a regular basis. So back in 2011, a few of my coworkers, Howard Zion, our Director of Technical Affairs, and Jeremy Sims, our Quality Manager, we were batting around some ideas for white papers, and we came up with this topic. We all thought it was a pretty good idea. So I did some research, and I kind of found out there really isn't anything out there that's published. I've heard a few other people say they haven't been able to find anything either. So we decided to run this idea by one of our customers, Mr. Bob Sutton from Terumo Cardiovascular Systems, and he thought it was a great topic. So I wound up writing a white paper on this, and I presented this at the national conference at NCSL. Our full paper is available on our Transcat website at the end of the presentation here. Well, after reading the 11-page paper, Bob Sutton called me up and told me, "That's a great start, Phil, but I want more. You have to do more." Well, Bob got what he wanted, so we put together a one-day hands-on seminar on evaluating out-of-tolerance units. So we have additional information available at the Transcat Consulting Services site if you want to look into more information on the, back up one too many. All right, so there are basically 2 things I hope you take away from the seminar today. One is to get some practical guidance on evaluating out-of-tolerance conditions through a systemic approach to help you concentrate your efforts. I can tell you, out-of-tolerance investigation aren't any fun. I've been in metrology for over 25 years, and I'd do almost anything to prevent from having to do another one, which kind of leads us to item number 2. Some key elements in developing a measurement assurance program. If you plan ahead, you should be able to help reduce your evaluation times, make them quicker and easier. So we got a section on that at the end. And today, you get a little bonus. I'm also going to offer up a few tips of the trade from experience myself and my colleagues that have gathered over the years. So, a few things here. Let's define a few things before we get going. Believe it or not, us metrologists have our own dictionary. We call it the Vocabulary of International Metrology, the VIM. It has a full page-long definition for calibration, but I'm just going to pare that down to something realistic here. So basically, calibration is a comparison to a metrology laboratory standard of known performance and uncertainty to the unknown behavior of a unit submitted for calibration. In the metrology world, we use the term OOT, out of tolerance. What does this really mean? It's non-compliance. It's when the unit under test does not meet the expected test limits. So talk a little bit about traceability. Traceability is one of those buzzwords scattered about our standards and calibration certificates. Fundamentally, the BIPM defines the standards of the SI units worldwide. The National Metrology Institutes, NMIs, such as NIST or NPL, they realize the SI units. They create the most accurate representation of the SI units. They're the guys that create the gizmos that actually generate the link standards. Then in our chain, we also have the primary standards laboratories. Their job is to disseminate those measurements across the world. And then we have secondary laboratories. These are the calibration service providers to end users. And finally, we have the equipment applications, the users of test equipment. These are most of our customers. These are most of you people out there, I hope. And then actually, I can add another one on the bottom. And that would be the consumers, your customers. All these things are interrelated. Each level is linked to the one above through calibration documentation to make a complete unbroken chain. So remember when I said we had 8,000 calibration standards? Well, for example, Transcat has a primary standards lab in Houston that calibrates all our multifunction calibrators. If they have an out-of-tolerance condition, that could affect all 100 of our multifunction calibrators across the company, which in turn could affect tens of thousands of customer units run across those calibrators, which in turn could affect the countless end products or services you're providing to the consumers in the market. So this kind of is a big deal. Statements of compliance. I can tell you from my experience as a lean manufacturing engineer and with the responsibility for 4 production cells, along with the calibration program as an additional duty, having to manage 3,000 calibrated items. The simple as-found statement was probably the most useful piece of information on my calibration certificates. So what does this mean? The statement as found in tolerance is a statement of compliance. It means that the entire instrument, all functions, parameters, ranges, and test points are within the calibration specifications at the time of calibration for the stated conditions at the location where the calibration took place. In essence, the calibration laboratory, staffed with its measurement experts, has completed an initial evaluation of your data. Not every lab is going to provide you with this compliance statement. Some labs may not leave it at all. They might just give you the data and the numbers and the uncertainty and leave it to your own devices to figure out whether you got an intolerance or out of tolerance instrument. Any calibration that's data only will not have any statement of compliance. Again, you're on your own to figure out whether the calibration and the equipment was adequate. Now, as found out of tolerance conditions indicates that at least one data point in a data report drifted or shifted beyond the allowable tolerance limits, which means the measurements the instrument was providing may not have been accurate. In an out-of-tolerance situation, the laboratory measurement experts have indicated that this unit had a problem and needs further analysis by you, the customer. And typically, the out-of-tolerance compliance statement is the trigger that starts off your corrective action system and your compliance system and your quality system. All right. So this is all why you're here. The investigation process. The object of the out-of-tolerance investigation process is to identify if there are any at-risk products due to the out-of-tolerance instrument. This process is designed to eliminate products without risk, narrow down your pool of at-risk products if there are any at the end. This is an investigation. I must caution you against having an end result already in mind. It's tempting to want to conclude that there were no at-risk units. Please don't start with a foregone conclusion. The investigation process will lead you to the appropriate conclusion, much like the evidence the crime scene investigator follows to lead to the guilty party. The data will take you down the path you need to go. Don't make any assumptions. It's very tempting, but refrain. So, what, when, where, and how? Yep, that's all there is to it. 4 questions and a little bit of math. I hope I don't lose anybody right now because this looks so simple, but the devil is in the details on this. And yes, I am presenting this in the sequence that makes sense. You'll get a little idea of this further down the line. The sequence that I follow does help you out in the long run. All right, so what? The first thing you need to do is to read through your calibration data to get a firm understanding of what specifically failed calibration. You need to identify what functions, parameters, ranges, test points. How many test points? Was it a linearity issue? Are there zeros out of tolerance? What are the test points at the limits? Are there some right inside the limits? This is all the information that can help you lead to better conclusions. The quality of the calibration and quantity of the data available can have a tremendous impact on narrowing your scope of investigation. This is why you need full calibration data as found and as left and uncertainties. The more data you have available to you, the better decisions you'll be able to make. All right, I have a simple example here. It's a single parameter unit with a single range device. In this case, it's a temperature probe. It has a range of -10 to 160 degrees Celsius. It has an accuracy of 0.06 degrees Celsius. On the data report there, you can see there were 2 out-of-point tolerant data points, 0 and 150 degrees Celsius. Below 100, it was intolerance. Okay? One little tip on that, make sure you're looking at the as-found data. Often you might get 2 sets of data. One says as found, one says as left. Make sure you're looking at the right set before you get going. The next area is when. Identify the time frame during which the questionable measurements have been taken. This objective is to identify a specific time when the instrument was last known to be taking correct measurements. Often this is going to be the as-left measurement data on a previous calibration certificate. This will provide you a good starting point to work from. Any effort you can make to limit the time frame in question will save you a lot of work later on. It's much better to only have to look at 6 months worth of data or 3 months worth of data if at all possible. Things to think about. Are there any preventive maintenance documents that you can look at? Is there any measurement data support a short time period to look at? Some tips. Document, document, document. Yes, I work and do audits. You must document everything. Things to look at and think about. Do you have any process control charts? Process control charts can help you limit your time frame to look at. Here at Transcat, we use SPRTs as temperature devices. On a weekly basis, we monitor these, and we take a 0-point reading. We record the resistance and the temperature readout of these. Every week we monitor these, and if they start to drift, to get to a certain point, we know that we should stop using it and send it in for cal. This limits our exposure to out-of-tolerance conditions. We also do mid-cycle checks or intercomparisons, or cross-checks as we like to call them in our industry. We do some comparisons on balances are a good one for this. A lot of people have a check standard. You got a balance, you put your check standard on once a day or once a week, take it off, you record the reading. For that day, you know that that balance is performing well based on that history that you have of taking those readings. Hopefully they're documented and you have something to look at. Calibration interval change policies. Are you looking at your calibration intervals? If your instruments were found out of tolerance last time, I hope you reduce the calibration interval. It'll prevent you from having another out of tolerance case. Do you have critical processes? Maybe you should have shorter cal intervals on the critical processes. All right, these are some things to think about. Did I mention documentation? Because if you don't have anything to look at, this isn't going to help you at all. Document, document, document. I'm a firm believer, as the FDA is. If it isn't written, it didn't happen. So cover yourself and make sure you get lots of documentation going. Okay, for an example here. I didn't have any other supporting documentation to identify a shorter calibration interval. So I had to go back to the last calibration certificate, say a year ago. So I say last year the calibration was done January 5th, so that's my starting point. And this year I'm going to start at January 15th. Why am I starting at January 15th? Why not January 21st? The point is, the laboratory received the asset or the piece of equipment on the 15th, which means it couldn't have been used by a customer in a process. It was already out of service. Document anytime your unit is removed from service. It'll save you time. If something is not being used on a regular basis, perhaps it's better to put it in a storage cabinet. Keep it from being used if it's not necessary. Where was the item used? This is probably the biggest challenge we have. We have customers ask us all the time, how do you keep track of your equipment? What's the better way to find things? This is probably the weakest link in the chain of traceability. This is where traceability most likely is going to break down, especially in large facilities. When you're using handheld equipment and bench-level test equipment, things have a tendency to wander around the building and move from station to station, hand to hand. A robust instrument control program that tracks the location for every calibrated unit is critical. At this point, you're trying to identify what department it was in, what areas it was in, what product lines it was used in. Couple of tips. Here at Transcat, our actual calibration certificate has 3 fields that our customers can use. Area ID and location. Use these fields. Identify what area. It's in the machine shop. It's asset ID number 624, and it's on the milling machine. Now you know exactly where this piece was, who it belongs to, and helps you identify where it is. Another tip I learned as a manufacturing engineer is that rack-mounted equipment has a tendency not to walk around very much. Nobody wants to unscrew those bolts out of there and move the piece of test equipment. If you can dedicate equipment and rack mount it, you'll know where it is and who's using it. 5S, visual management, shadow boards. Put your test equipment and workstations up on shadow boards. Think about using tool cribs. Sign equipment out, sign equipment in. These are things you can do to control where things go and where they are and who's using them. Consider electronic tracking systems, barcodes, RFID tags. Assign workstations and workbenches. Here at Transcat, we track electronically every one of our laboratory standards. At any given time, I can identify where a piece of test equipment is. Is it in our Anaheim facility? Is it in our Boston facility? We do move equipment around. We transfer equipment properly, and we track. At Transcat, every measurement has a date time stamp and also includes the assets numbers that every measurement was taken with. So at any given time, I can identify specifically which measurements were taken by what asset in what location at any given time frame. Trust me, we've been through this a lot, and we know how to keep track of equipment. It's a very robust system. Without it, you could be at a loss. So, again, here's an example. Use the full field identification. Look down in the left-hand side. You have area, unit ID, and location. If you don't give us the information, we won't populate it. If we only have an ID number, that's all that'll be in there. In our case here, our example, the unit was only used in the thermometry lab. I was able to track it down and say, okay, this is where it is. This didn't go anywhere else. It was only used in the Rochester lab, only in the thermometry lab. So, how was it being used? During the time frame in question, in all locations where it was used, were the out-of-town's parameters and ranges and test points. You need to check. End-user procedures, work instructions, engineering specifications, process documentation. The objective at this step is to determine where out-of-tolerance instruments could have affected any product. Remember, we're not trying to determine the impact yet. We're not making any decisions here. We're still collecting evidence. During one training session, we identified an issue that there was a revision change in one of our procedures during which the time frame was in question. So we had to go back and pull the reference procedure for the previous rev to see if the process tolerance had changed. In our case, it hadn't. So it was just a lesson to be learned to look at all the previous revisions of your documentation. So at this point, if you've answered no to all these questions, congratulations, you don't have any recall analysis to do. You finished it. You know that nothing was impacted. For example, I like it when we have, say, a Fluke 87 is found out of tolerance at the 10 millivolt range, 50 kHz. I can almost assure you that we never take a measurement at 10 millivolts and 50 kHz. But you need to go through this entire process and document all these steps. And in the end, if you're lucky, you come up with that, hey, there was nothing to look at. You can close the investigation at this point in time. But make sure you write all the documentation down, because your internal auditor, an FDA inspector, or somebody like me is going to come around and say, hey, why don't you show me some of that documentation as how you came to that conclusion. So for our example, our little thermometer was called out in 2 calibration procedures. In one of them, the cal procedure says to use it to monitor a 25-degree bath. And let's say the other cal procedure says to monitor a 100-degree bath. So we figured out how we're exactly using it now. Now's the time to start analyzing the impact. Okay, so what do we know? We know what was out of tolerance, when it was used and when we have to worry about it, where in our processes it could have impacted, and how it was used. Now you need to assess the error. Did the error impact products? You need to identify the magnitude and direction of the error and determine the error impact on any products. There are basically two questions. What's the error of the UUT, and did this error change any of our pass or fail criteria for our customer products? So, in our example, what do we know? All readings above 100 degrees were out of tolerance. We need to look at all products between January 5th, 2014 and January 15th, 2015. We only need to look at the thermometry lab, and it was only used, the out of tolerance point was only used in the 100-degree bath. We don't have to worry about the 50-degree bath because at that point it was still in tolerance. That was not out of tolerance, so we don't have to look at anything that was run in the 50-degree bath. We just have to be concerned about the 100-degree bath. The magnitude of the out of tolerance portion was 0.4 degrees. And our thermometer was reading too high. Okay? I don't have enough time to get a variety of cases that you could run across, so I'm going to stick to this simple, straightforward one, okay? You can run across cases where you have no measurement data. You have data that's low rather than high. There's lots of situations. I have a couple of case studies in the white paper to discuss some different approaches to this. So we'll move forward with this simple one. So what we need to know is what product would have read, what products would have read at 100 degrees Celsius. We thought our bath, which was set for 100 degrees Celsius plus or minus 0.06, but our UUT quote was lying to us because it was out of tolerance. We didn't know it. You can't tell until you send it in for calibration. The thermometer was actually reading 100.1 degrees. It said 100.00, but in reality, really delivering, that bath was really set for 100.1. Okay? Now, assuming you have some product measurement data, and I hope you do, because then you can really answer some questions, we're going to determine and correct for the unexpected error. Our unexpected error is the 0.4 degrees that it was past the tolerance limits. Okay, this is where a little bit of this uncertainty stuff comes into play. You selected this thermometer because it had an accuracy of 0.6 degrees. So you allow your process to wander plus or minus 0.06 degrees, and it's okay. That's fine. But it wandered more than the 0.6. It wandered 0.4 beyond your 0.6 limit, right? That's the unexpected error. Okay, so we're going to correct and determine what our product should have been reading had our thermometer been accurate within its operating expectations. Since the UUT was reading too high, all products readings will also be too high by the amount of the out of tolerance. Since all reported product readings were too high, we must subtract the UUT's error from the product's reported readings to get the product's actual behavior at 100 degrees. Now recheck your product indication against the process tolerances. Okay? So when you first read and recorded your product, it read 99.90. Now we had an unexpected error of 04 degrees. So now in reality, if the bath was correct at 100, then your product could have been reading 99.86. This is what you need to check against your process tolerance. Is that reading still okay? Did it still pass your product tests and your product tolerances? Okay, not too bad. Now just repeat it for every other instrument that you had in that whittled down list. We have assets and equipment that we run over 5,000 pieces of equipment on in the course of a year. I don't like having to do this on 5,000 pieces of equipment. All right? So, at this point, you can conclude in your analysis. All right? What happens after this is business decisions. What are the consumer risks? Do you need to do a recall? Do you not need to do a recall? What is the potential cost? These are all business decisions. Your technical analysis is done. Okay? It's a little controversy here, but I can't get into too much detail here in the allotted time I have. Okay. So, measurement assurance programs. If you design your measurement assurance program, you can help limit all your time you spend on these things. The measurement assurance program is more than a calibration program. It's thought process. It links the related measurements through the entire product life cycle, from concept to end product. Hopefully this approach and guidelines will ease the burden of solving one of these most dreaded situations in the measurement world, the evaluation of out-of-tolerance instruments. If you begin with your R&D product specifications and you work from there and build your manufacturing process documents, at this point I would suggest that you identify your critical measurements and set warning tolerances. I had one customer I went to that they had process tolerances. They would say, okay, my oven needs to be 100 degrees plus or minus 10 degrees. That was their process tolerance, plus or minus 10 degrees. Well, they in turn set warning points of plus or minus 5 degrees. And from the warning point, they selected test equipment to monitor that 4 times better. So they had test equipment that was plus or minus 1 degree. And then they selected a cal provider who could provide a calibration 4 times better than that. So plus or minus 0.25 degrees. So even if their thermometer exceeded their plus or minus 1 degree limits, they still had significant amount of room to maneuver. This was a very good system. They had done this for every measurement device they had. They had warning tolerances. So they knew that even if something was found out of tolerance, unless it was out of tolerance by 2 or 3 times the specification, they really didn't have to worry about anything. They were really smart about this. They followed this type of thought process. They selected the corrected test equipment. They planned it. One other recommendation I would have is single parameter test equipment versus multifunction test equipment. Our little example here I went through is a single range, single purpose device. If I had a multimeter which can measure AC volts, DC current, resistance, temperature, SPRTs, thermocouples, if you have an out of tolerance condition on any one of those things, you need to do an investigation. But you only use it for DC volts. Why would you use a multifunction instrument if you only need 1 parameter? Limit them if you can. Pay attention to your accuracy ratios like the customer I already mentioned did. They picked stuff correctly. They did a very good job of determining what they really needed. For your quality control program, think proactively. Think about process control charts for these critical measurements. If temperature is a critical measurement for you in your process, maybe you ought to do something else to monitor that to prevent you from having to do this. Think about mid-cycle checks, cross-checks. And have a very good preventative maintenance program. Really, calibration is a preventative maintenance function. It's like insurance. It's nice to have, but boy, it's really nice to have when you need it. Always get calibration with as found and as left data and uncertainties. And have a calibration interval adjustment policy. Be smart about your calibration. If an instrument couldn't hold its specifications after 12 months, reduce it. Reduce it to 10 months. Select a shorter time frame to find out what interval it will hold its specifications. So, in summary, we talked a little bit about how to conduct an out-of-tolerance investigation and a few elements about a measurement assurance program. The cost of a single product recall will far exceed any costs associated with time spent in the 4 steps on the investigation process, which eliminates products to be analyzed, is well worth the time. Remember, the overall objective is to filter out as many possible items that do not need closer analysis so you can get to the ones where the detailed analysis is required. All this evaluation analysis is a tremendous amount of work. A well thought out electronic system linking your instrumentation to processes and product traceability as part of a measurement assurance program can ease the burden of these evaluations and analysis. Okay, that pretty much wraps up my discussion part.
Great.
About 40 minutes, not bad.
Thank you, Phil. So we'll move in. We've got a couple of questions here that we will move into, and if anybody has any, please feel free to add them to the question box. The first question was, great point to emphasize on not making assumptions of impact of beginning an out of tolerance. So that was just a comment. Next question was, Phil, what do you do if an instrument has been borrowed by another area and it hasn't been recorded?
Oh, that is a tough one. Really, the only thing you can do is talk to the people that actually do an interview to see who's using it and what they were doing. If you don't have any written evidence, paperwork or traceability trail like that, talk to people. Document it, though. Because if I'm going back behind you, I want to know what steps you took and who'd you talk to and what they believed they used it on. You might not have any measurement data, but at least you're documenting where it went.
Okay. Do you have any thoughts on assuming a linear drift and then determining the month that the item went out of tolerance?
In the analysis phase, you can take many different approaches as to trying to figure out this type of thing. I have done linear analysis. It kind of depends on how much data you have. If I've got a single data point on an entire range, I have to assume conservatively that the entire range would have been out of tolerance by that same amount. If I have multiple points on a range, like our little sample there, in all likelihood, our little sample went out of tolerance somewhere between 50 degrees and 100 degrees, because it was in at 50 and out at 100. I would probably do a linear regression and try and estimate that point with which it went out. In our case, in our sample, it wouldn't have mattered because we only use it at 50, or we only use it at 25 and 100. So yes, I would take a look at it, but whatever you do, document it.
Okay. The next question is, how important is the 4-to-1 accuracy ratio?
Well, 4 to 1 gives you a conservative approach. If you cannot get a 4 to 1 test uncertainty ratio, and there are cases that you just can't do it, those might be the situations where you might consider reducing your calibration interval, put some extra checks and balances in to give you that confidence that your measurements are accurate and stay accurate. 4 to 1 is no guarantee of anything, but it is a stake in the ground and gives you a point with which to work from.
Okay. Are there out-of-tolerance conditions that go in 2 directions, both plus and minus from the expected set point?
I'm sorry, you say that again?
Are there out-of-tolerance conditions that go in 2 directions, both positive and negative from the expected set point?
Sure. If I have multiple points on a range, I could have one point that's too high and then the bottom end of the range too low. It's possible to happen. Again, that might be a case for your linear analysis then.
Okay, we've got a couple more questions that have come in. One person asked if we could send the slides after the show. After the webinar is concluded, we will compile both the recording and the slides. You will get an email with the links to our website, all our previous webinars, and there was also a question about the white paper, are located on our website at Transcat.com. If you click under Calibration Services, there's a link for Calibration Academy, and all our white papers and previous webinars are on the site. Another question has come in. Does Transcat have a process in place for standards received inoperable or lost standards?
Well, if something comes in inoperable and you just cannot get any data from it, there's really little to no analysis you can do with it. Hopefully, if it was inoperable, it was a catastrophic failure. So you kind of, if it works or it doesn't work, you kind of know when it fails, and hopefully your people are reporting failed equipment. Our process, we do have as found conditions as op-fail. So we do see those occasionally, and you'll see different as found annotations on there.
Okay, how do you justify extending a calibration interval when you have gauges that continue to be within tolerance?
That's a business decision on when to extend calibration intervals. The NCSLI RP series offers several different methods to extend or shorten calibration intervals. Some are simple, some are complex. It is a cost savings to extend calibration intervals on equipment that have demonstrated stability over a long time.
Okay. Would you recommend to reduce an interval on its first failure?
Absolutely. For us, I would absolutely reduce its failure, the interval on initial failure. Again, that's when I say you must have your own policy and procedure on it. On our laboratory standards, if something is found out of tolerance, our requirement is to reduce the calibration interval.
Okay. When you evaluate intolerance versus out of tolerance, do you include uncertainty in your calculation? If it is borderline and the uncertainty would put it out, which way do you call it?
Okay, yes. This is a good question. It's a long question. I don't have time to give the long answer, but I will say this. You need to understand, that's called the decision rule. What decision rule is your vendor providing? Some vendors will not have a decision rule at all. If it gets into that borderline, they say, it's indeterminate. Well, that's no help to you either. Transcat's policy says if your measurement data is on the limit or less than the limit, we will call it intolerance. Okay? That's our defined decision rule. We can talk about it in more details, but there are a variety of different decision rules that you can apply. It's key to understand what your provider is using.
Okay. What about out of tolerance on custom gauges?
Well, custom gauges, the customer is identifying and setting the specifications. So you give us the tolerance, we'll tell you if it passes or fails. It's your choice, your tolerances.
What asset tracking system do you use?
Transcat uses our own internal proprietary system, CalTrack.
Okay. This is based on a site with 3,000 plus calibrations per year across many types of instruments. I guess that question did not come through complete. On the calibration certificates, please explain the cal process uncertainty, the measurement uncertainty, and the TUR.
I'll refer you to give us a call, and we can talk about that one-on-one. It's too difficult to explain that information over the phone in the short time we have. Okay. Call our quality department, Jeremy Sims, quality manager.
If the calibration is being performed by the OEM and they do not have standards traceable to NIST, how do you go about defending this to regulatory bodies?
NIST is not the only accrediting body out there. Okay, that's a long-term discussion getting into traceability functions. Some items we use, like fixed point calibrations on your SPRTs, they're defined by the ITS 90. If I have those fixed point cells, I have the realization of that temperature point. The triple point of water is 0.01 degrees Celsius, period, by definition. If I have a cell, I have an artifact of 0.01 degrees. I don't have to send that cell to NIST or anybody else. It's an intrinsic standard. So not everything has to go to a accrediting body or an NMI. Read the notes and the fine print on your calibration certificates for a little more information on that.
How do you take the uncertainty calculation into consideration during the analysis?
I think we already addressed that. That comes into play with your decision rule.
How do you control limited calibration equipment?
Well, again, that is policy and procedure locally. We identify items as limited calibration on our calibration labels and on the calibration certificates. The users of that test equipment must be aware of those limitations. So that's an education on your point of the end user.
How are the BIPM and the NMI connected in the traceability pyramid?
BIPM defines as SI units. They don't actually have any labs or anything. The NMIs are the ones who create they're the ones who design the fixed cell for the triple point of water as the melt points. They create and design the test equipment that everybody else winds up using for these highest level accuracy measurements.
Okay, for less than 4:1 TURs, is guard banding considered the only solution?
No. Less than 4:1 TUR doesn't necessarily indicate a bad calibration or a poor calibration. It just means there's inherently additional risk, and you can input other controls to limit that risk.
During an investigation of an out of tolerance, we typically start the investigation with repeating the 5 most recent calibration performed with standard X. These results depend on how much more we investigate into this issue. Is this typical?
No, I haven't run across anybody who does anything like that before.
Do you receive anything stating that you participated in the training for our records and employers? The only thing that we could wind up sending you is the confirmation of the attendance by sending you the webinar information. We don't provide any certificates from our calibration or from participation. Next question. Does test equipment in the field need to be checked for intolerance before and after calibration, or use the standard 1-year frequency?
The calibration intervals that you choose are highly dependent on your usage. It's situation dependent. I can't recommend any type of calibration intervals, and neither can any accreditation body. It's a violation of 17025 for me to provide a recommendation on a calibration interval. It's conflict of interest. If I had it my way, I'd have you calibrate it once a month and charge you $500. So
Do you ever lengthen the calibration intervals for equipment that's very rarely used?
Yes, we do. If equipment isn't used very often, for example, optical flats that we use, they're quartz, they're very stable, and as long as they don't get scratched, they don't change in value. We typically will put something like that on a 2 or 3, 4, 5-year interval. Instrumentation that isn't used very frequently in the mechanical world, thread gauges, thread plugs, and pins and rings like that. As a manufacturing engineer, I used to use keep track of a usage log. So I might use one ring gauge only once every 2 or 3 months. I would not send it in for cal every year. I would send it in for cal after 50 uses. Well, 50 uses might take me 2 or 3 years to get to. So that's one way you can approach taking infrequently used equipment.
Okay, we've got more comments still coming in. What is the lowest calibration interval that you can use in the case of a multiple failure?
Well, if I get multiple failures, and honestly, if it's less than 30 days, I'm probably going to replace the piece of test equipment. At some point in time, the cost-benefit, the return on the calibration cost versus a better unit or a new unit will exceed your calibration cost. So that's kind of a business decision.
Is it better to write the actual values on the reports or just the deviations?
Well, that's kind of a personal approach. Personally, I like to see the actual displayed value. 17025 requires you to report the observed indication. Displaying a deviation is a mathematical calculation. Who's doing the math? Is it built into your program? Or is it a technician with a calculator? Or is it a technician with his head? A couple of those things are more prone to having errors.
Okay, where's a good place to start for someone seeking certification as a calibration technician?
ASQ website. American Society for Quality is a very good body of knowledge information on how to take the calibration CCT, and the Metrology Handbook published by the ASQ is an excellent source for understanding the overall basics of metrology and calibration.
Again, we've had a couple more comments come in about receiving copies of the materials. We will, in a few days, send an email with a recording and a copy of the slides to everyone that both attended and registered, so everybody will have a copy of the information. Another question, is there any guidance on how to define acceptance criteria, for example, a turbine flow meter?
Acceptance criteria? I am not familiar with turbine flow meters. I couldn't tell you where to begin other than discussing with the manufacturer what their initial recommendations are and finding a way to validate the readings that you get on your installation.
Okay, what do you suggest if the customer you're doing calibrations for does not have travelers for their tools only outlined by their departments? How do you suggest approaching 52,000 tools to have better locations and reports of where they are and where they go?
As I've said, those are some real challenges. Large facilities, that's a bear. You give us a call and we can talk, you know, but there's no off-the-shelf system that you can do that's going to track things. Over the years, I've looked at RFID tags and everything else, and the technology for RFID isn't quite there yet for small tools. Typical small tag RFIDs are passive, and passive things you just can't find. That's a tough one. There's no simple answer.
With some of these more complicated questions, one option that I'd like to offer everyone is on our website under the calibration services, we have developed a forum. It's called Ask the Expert. So if we don't get to all the questions or if you have others offline, you can please feel free to visit our website. enter your contact information and your question. We'll have one of our resident experts get back to you with the information. We've got time for a couple more questions here that have come through. How do you define the risk for attribute gauges that have been found out of tolerance?
I can't define the risks for you. You have to look at your processes and what you're using them for. We can help offer some guidance, but I don't know how you're using your test equipment. You've got to go talk to the process experts and the manufacturing engineers in your facility to see what those impacts are on your processes.
Okay, how do you conduct a calibration program for a supplier?
You need a little more information than that. I'm not exactly sure what you mean by conduct a cal program.
Okay, somebody asked for us to repeat the name of the site for becoming a calibration technician.
ASQ.org, I believe.
Okay, and then for calculating the corrected value in light of an out-of-tolerance standard, why use an expected error instead of the entire OOT amount?
Well, that gets into uncertainties. When you purchase your test equipment, your accuracy is plus or minus some amount. You expect it to move that amount somewhere, right? That's uncertainty. That's unknown. When you take a measurement with anything, the value could be anywhere within that zone, right? In essence, what you're trying to do there, if you use the entire error, is you're trying to normalize every reading. But that plus or minus, in our case, 0.6, at any given time, it could be plus 0.1, plus 0.2, minus 0.3. I don't know exactly where it is at any given time. Same thing with your process. You expect your process to wander. That's why you have process tolerances. That's why you define and selected your test equipment with those limits. You can live with the test equipment moving that amount of known variation. It's the unknown variation that you have to be concerned about.
Okay. Does Transcat notify its customers if one of Transcat's calibration standards was found to be out of tolerance?
Yes, we do. If we do our investigation and we find out that we could have affected your unit, we will send out a notification, and we have over the course of years. I've sent out a handful myself, and it does happen. And I've actually received 1 or 2 notices from OEMs before. Now, many of our processes are under such tight controls, and we have such good TURs. Our out-of-tolerance conditions do not impact our customer test equipment. So that's the advantages we have by all our process controls. We know before something catastrophic happens, and we limit our exposure and our risk.
Okay. Is it not a good idea to perform the calibration of an instrument in ambient conditions, of actual normal condition of the instrument during use instead of the controlled condition of a calibration lab?
In a calibration lab, essentially calibration is a controlled experiment. We need to control as many variables of the equation as possible. That's why mechanical test equipment is tested at 20 degrees Celsius, right? 68 degrees Fahrenheit, 20 degrees Celsius. If you look on mechanical drawings and you look in there, somewhere there should actually make a statement that the tolerances and readings on mechanical drawings are valid at 20 degrees Celsius, okay? If you take measurements at other temperatures, you must compensate for that difference in temperatures. Our precision test equipment in the electrical laboratory operates at plus or minus 5 degrees from the calibration temperature. The electrical laboratories operate at 23 degrees Celsius, plus or minus 5 degrees. If I take my laboratory standards outside of that temperature, my laboratory standards are not as accurate as they are in the laboratory. If I take them on site, I must add additional uncertainty to all the data I report. It is highly recommended to take calibration in a controlled environment.
Okay, and this will be our final question for the afternoon. Even if your TUR are low enough not to jeopardize the results of a calibration, are you not obligated to report that to the customer, that the uncertainties reported on the certificate may not be valid?
Well, Transcat policy is that if our TURs are less than 4:1, we will provide you the TUR and the actual measurement uncertainty. So I hope that actually answers your question. That's our policy. I can't say the same for any other manufacturer, OEM, or Cal service provider.
Okay. We'd like to thank everybody for joining us. Again, if there are any further questions, you can feel free to visit our website and click into our Ask the Experts forum. And if anybody has any suggestions for future webinars that you'd like to see from us, you can also send them through our website as well. Again, this concludes our webinar for today. Thank you very much for attending, and have a great day.